This video is on the primary lymphoid organs. The primary lymphoid organs are where the immune cells develop. Both the T cell and the B cells develop in the bone marrow. The T cell then moves to the thymus to fully maturate, and the B cell moves into the secondary lymphoid organs to mature. The primary lymphoid organs are the bone marrow and the thymus. The bone marrow sits inside bones, primarily the pelvis, ribs, sternum, vertebrae, and the long bones. The inside of these bones is filled with a trabeculated, spongy material where the HSCs live. The outside of the bone is termed compact, while the inside is termed cancellous. The cancellous bone contains an endosteal niche lining, the compact bone, the perivascular niche lining, and the blood vessels that run through the bone. The active HSCs tend to be in the perivascular niche. The endosteal niche contains the osteocytes, or cells that make bone, the bone matrix, and the quiescent HSCs. Since the bone marrow is the site of the HSCs, all the cellular elements of the blood are formed in the bone marrow. The cells of both the myeloid and the lymphoid cell lines start in the bone marrow. The progenitor T cells will migrate to the thymus to mature, while the progenitor B cells develop in the bone marrow and then move to the secondary lymph organs to become activated. The thymus is an organ that sits on top of the heart. It is largest in size in the child and gradually shrinks in size in the adult. The thymus has two lobes which are divided into a centralized medulla and an outer cortex. The immature T cells, or thymocytes, arrive at the thymus. Once there, they mature, meaning they can react to antigens presented to them, known as positive selection, but not react to self-molecules as if they were antigens, known as negative selection. When the T cell has passed both the positive and negative selection, the T cell can then leave the thymus. If the T cell does not pass either of the selection processes, the cell undergoes apoptosis. This process can take 1 to 2 weeks to complete. There are several diseases attached to a malfunctioning thymus that lead to an immunodeficient state. One such disease is DiGeorge syndrome. Here, there is only a small deletion of chromosome 22. Not only do these people have decreased numbers of T cells, but also suffer with various forms of congenital heart disease, learning difficulties, kidney problems, and often suffer from seizures and schizophrenia. Some individuals have minor symptoms, while others are quite devastated. The DiGeorge individual will suffer from bacterial infections, and since they lack cytotoxic T cells, there can be an increase in viral infections. They also lack the helper T cells that supply the B cells with the antigen support they need to produce antibodies. Individuals with DiGeorge syndrome tend to have problems with bacterial, fungal, and viral infections if they have a severe loss of T cells. But the T cell function in DiGeorge syndrome varies from mild to severe. For some unknown reason, these individuals also suffer from autoimmune problems. The primary lymphoid organs are the source of the B and T cell development and function.